Okay, hi and welcome to Notes 8.8. It's exponential growth, but this is about money. So we're going to call this compound interest. And with compound interest, we add in a new term, which is compound. What it means is how many times you get your money. In the real world, banks don't just give you your money if you put money into their account once a year. Sometimes they give it to you semi-annually, twice a year. Sometimes they give it to you quarterly, 4 times a year. Sometimes they give it to you every day. That's what we call continuously. Actually, that would be daily. Then there's a continuous one where they give it to you all the time. So each one has a different aspect. Sometimes you make a little more money, sometimes you make a little less. But that's what this is all about, how much money you get and how it's compounded. So it's our growth formula, but the B part looks a little different. So let's go ahead and get right down to it. Here's a definition of a bank paying interest and the principal being a part of it. Let's talk about what the principal is here. Principal is the initial amount of money that you'd like to put in there. Hey, I use the terms initial amount of money. And then the interest is your rate, percent, your percent of rate. Okay? And your principal is the initial amount. Why did they change the name? Well, because it's money-based. And because it's money-based, they wanted to have a special terminology, ones that they used with dealing with money. So we'll leave it at that. So now that we kind of have a general idea of what's going on here, we're going to take a look at the actual function. And you'll notice that it looks a little bit different from what we're used to. Let me write down what the function is for a growth formula. Right? So it's going to be some form of y equals our initial amount times our growth factor b. I should not use a capital B. I'll use a lowercase, capital B raised to the x. And that's an exponential function. This is just a modified version of an exponential function. And we've seen this with our rate problems previously when we did this in the last section of notes. This one has an addition to it when we do it. Now remember that this one right here means 100% of the original, so we'll recall that. So whatever you put into the account, that accounts for that first 100%. The R here is the rate that you're going to receive on top of that original amount. Okay, and then the X, which is here, that's your time periods or number of changes, right? Usually number of time, we'll put time because that's usually what these will account to. But you'll notice the new part here, because those are all common to the other form. So let me write down the other form so that I don't get too far away. We said it was 1 plus r raised to the x there. That's the rate formula, the general form of rate. But when we introduce the concept of compounding, they give you your money more frequently, but they only give you that equal portion of it that frequently. So, because if they gave it to you more frequently, you'd actually make more money. Well, they're not going to give you more money. They're going to give you whatever your percent increase is. So let's say it's like 8%. That would be huge. You never get that amount of money. But if they gave you 8%, they're going to break it up that many times. You're going to divide it by however many times you're getting it extra. So if you get it 4 extra times, they're going to divide it into 4. So if you get it 12 extra times, they're going to divide it into 12, and they're going to give you 1/12 each time. So that's really what this compounding is. Do you need to know it? Yeah, unfortunately you do. You need to kind of have an understanding of what the compounding is so you can answer these questions. Is this generally an area where kids may get tripped up? Yeah, there's a lot of parts here. And anytime we have more parts, individually they're easy. And if we look at them that way, we're fine. But sometimes students forget that and they kind of look at the whole thing at once. Don't do that. Now I know I've got a lot of writing on my screen, but we'll break it down piece by piece. Really, it's just going to be recognition of each part and then plugging in your calculator. Nothing difficult about it for you. So let's take a look here at the different types of compounds. Again, these are the different versions. You do need to memorize these. Okay? When they say the word annually, you need to know that that means once per year. If they say semi-annually, which describes itself, it means twice per year. If they say quarterly, you know that that means 4 times a year, and monthly means 12 times a year. You need to memorize those so that you have those memorized. These are just examples of how that works. If you got 8% every year, and you got it semi-annually instead of annually, they would take that 8%, they would divide it into 2 4%, but you would get it twice as often, or so every 6 months. Okay, so there's that idea of that compound interest. So let's see if we can take a look and tackle one of these. Okay, in your homework, I want you to write the base form of this each and every time you start a problem. So every time you're given one of these, you're going to write the base function, okay, which is your balance of your account with your principal, your initial amount, your 100% of your original, plus the rate that it's increasing by, over the divided by the number of compounds, times the number of years that you have it in there, times how many times you get it compounded. Okay, so you're going to write that function out each and every time. Additionally, I want you to label these parts so that I can see that you're identifying it. So I can see that you're putting the correct formula in, and I can see what parts you're putting in there. So I'm going to ask you to do that for each homework question from the book that you will receive on this. So let's see if we can identify some of these parts. It says, suppose your parents deposited $1,500 in an account. Well, right away, we know that this $1,500 means something. That's the initial amount they deposited in the account. Or your balance, not your balance, but your principal, your initial amount. So there's your $1,500. Okay. The account's paying 6.5 interest. That's your rate, your percent that you're making on top of your 100% of your original money, which is $1,500. But 6.5%, we don't use percents in calculations. Instead, we change it to a decimal, and we know that that equals 0.65. All right, and then it says it's compounded annually. So our compound, which is our n, is just going to be 1. Okay, that's the simplest form of this. It actually takes away the compounds and gets us back to a regular rate problem that we've done before. Now it says, they put that in when you were born, find the account balance after 18 years. Well, guess what? 18-year period. That's nice and simple. So let's go ahead and plug in all the parts here. Your balance of your account for $1,500. 100% of your original at 0.065 compounded by 1, which means 0.065, and the number of years is 18, again multiplied by the number of compounds, which is 1, so it doesn't change anything. So if you put that in your calculator, clean it all up. Well, let's clean it up so that we can see what it really looks like. Never leave it like that. Go ahead and do this step, as silly as it looks. I want you to see what it actually will be. So there's exactly what we typed in the calculator. You could type the first one in the calculator, but you're more apt to make a mistake. So please type in what we have here in the second line. So put that in your calculator. What you're going to find out is that you've made over 18 years of doing nothing besides gaining 6.5%, which they never do anymore. You're going to make what that looks like $3,000 on top of it. What's awesome. You have $3,000 for doing nothing. Fantastic. These must be written in context, so you do have to rewrite these. After 18 years of compounding annually at 6.5%, the balance will be $4,659.98. I could have probably tossed in there a line about, with the initial amount or a principal of $1,500, but we're okay like that. All right, the second problem here, I'll let you look at. It's the exact same problem, nothing's different, but let's look at what they're asking us to do here. It says, suppose the interest rate of the account in example 2 was 8%. How much would it be? So all they changed out of all the information, same $1,500, same annually, same 18 years, the only thing they changed was our rate. And so how much more money did we gain by that? Well, look at this. We started at $4,600 and now we're at basically $6,000. That's a $1,500 increase by going from 6.5% to 8%. That's a huge amount of money for such a little change. Again, you'll never see 8% unless you're in some kind of equity fund, but that's even a small chance of that over 18 years. But we can see the change of adding and increasing our rate and what's happening there. All right, so let's go down to another problem where we get actually to do some compounding. This one says compounded quarterly. You can see I have it highlighted here. So that means that my compounds are going to be 4. So I'm going to go ahead and add that in because I started there. So my number of compounds, my n, will be 4 times. Okay, we're still looking at the first example, so we know that our principal is still $1,500. We know that our rate then is back to that original 6.5%, which is 0.065 as a decimal, and we know it's over 18 years. So let's write the original problem here. Our balance is equal to our principal times 100% of our original plus our rate divided by our number of compounds raised to the exponent of the number of years times the number of compounds. That's our original problem. I asked you to write that each and every time. So there we go. Now all we have to do is plug the parts in and put that on our calculator. So our balance is equal to our $1,500, our 1 plus our rate, which is 0.065, divided by our number of compounds, so this is 4, and then we're going to have our 18 years, but we're going to get it 4 times a year. So we multiply that by 4. So we do need to clean that up. I don't remember, we'll pull up our calculator, I don't remember what 0.65 was divided by 4, so we'll check that. Oops. 0.65 divided by 4, so that we can change this in the form it should be. So now we're going to have 1,500, pull that back up because I didn't read it, so we're going to have 0.01625, so 1.1060, ooh, I don't think I did that right, did I? 0.1625, let's change that. 0.01625, right? That's adding those two together. And then 18 times 4, again, let's check our calculator for that. We'll find out that it's 72. So what we'd enter into our calculator is that. And when we get that out, we're going to find that we made $4,787.75. Well, how does that compare? In this one, that's our base rate, 6.5%, $1,500, 18 years. This one, we increased the rate that we were getting, jumped up $1,500. This one, we went back to that original rate that we were getting, but this time we got it paid more often. We got it 4 times a year as opposed to once a year. What did that do? It made us more money. That's what compounding does. The more frequently they compound your amount of money in an account, the more often you get it, so the more often your your principal grows, and then it gets that extra interest. So you can see you actually want as many compounds in your whatever your account is that we're dealing with is possible. All right, and the last problem here, you can see that this one goes back to compounded monthly. So now we've increased the number of times that our compound takes place to 12. It's still at 6.5%. It's still the original $1,500 at 18 years. And you can see that that works out to be $4,800.53. So we got a little bit more, but you can see that the compound's actually going to top out. So if you get it continuously, you'll make a little extra money. What we want to notice is that the biggest change or the biggest effect on your money is increasing your rate. That's actually what you want to do. So now you've got a little bit of knowledge for your account. When you get a little bit older and you decide to put some money away, now you have a little bit of information. You're on your way. This is definitely not all of it, but it's a good start. All right, so I'll see you in class for some questions, and we'll have a good time with that. All right.